On the Fourier analysis and the later part of the equation, you introduce Cn and Dn. Are they, what are they for?
Well, CNs are related, are complex versions of the Fourier coefficients AN and BN, okay? So CNs are the Fourier coefficients. Okay, so when you take a function and you Fourier analyze it, next second, somebody wants to come in. So when you take when you have a function and you want to Fourier analyze it, you have to, so this is basically we're looking at the Fourier series. So f of x is a periodic function. And when you want to Fourier analyze it, you're expressing it in terms of some basis functions, which are e to the power 2 pi I n x over L. But, the magic sauce is how much of each function do you include in this linear combination. That is determined by the coefficients, the Fourier coefficients.
Okay, and in the series, you wrote a0 divided by 2 specially away from the summation sign. So a0 divided by 2, is that some special or something?
The a0 is basically the constant part, right? Because when n is 0, then this thing is the coefficient is just 1. The basis function is 1. So a0 is like the constant part of the it's most of the cases a0 will be probably it's just a convention. You can always redefine a0 to be twice a0 and the half would go away.
Okay, got it.
Okay, and the d's are defined by this partial sum, and the partial sum goes from minus n to plus n dn e to the power 2 pi I n x over L. Okay, so the partial sum is a approximation to this series. So this is not the Fourier series. This is some random finite series. And the coefficients are dn here. And what we showed is that, in the sense of the least square, the partial sum is good at approximating this function if dn is equal to cn. Okay.
Okay, got it.
Okay. All right. Any other questions? And by the way, the other thing is that in the limit where the period goes to infinity, the CNs, they become AK, right? The Fourier transforms. Okay, we defined that. Okay, any more questions?
About Parseval's identity, is that just saturated Bessel's identity?
Yes.
Okay.
All right. Any other questions?